For about 4.5 billion years of our solar system history, the Earth hasn't been alone while we revolved around the Sun. Our giant lunar companion is larger and more massive than any other moon when compared to the planet it orbits, and when it's in full phase, it brightly illuminates the night and linked throughout history to phenomena such as lunacy, animal behavior, such as howling at the moon, and even women's menstrual cycles. While those links don't stand up to scientific scrutiny, there are many ways the moon actually does affect the Earth. But what would happen if it suddenly waves the Earth goodbye? Could Earth survive without its crater-faced little brother? The closest object to our planet, the moon, may seem like Earth's little sibling. Since its birth, the satellite has mostly just hung around, playing gravitational tug-of-war. And if we all woke up one morning to find the moon missing, most of us probably wouldn't notice, because those who live near the oceans would find the tides reduced, but not completely absent. While the moon does most of the gravitational tugging that creates our tides, the sun also plays a role. Coast dwellers would notice tides less than half as big as they are now. The moon's earthly impacts. A missing moon could cause even more disruptive changes, although on a much longer timescale. Without the moon's gravity holding the Earth in place, the tilt of our home planet's axis would probably shift drastically over time. Earth could go from no tilt with virtually no seasons to a drastic tilt with extreme seasonal weather changes and ice ages in just a few 100,000 years. Destroying the moon would result in approximately the ocean tides would completely stop. With the gravitational pull of the moon missing, tides as we know them would be over. There would still be waves, since the sun also slightly affects the movement of the ocean, but the churning currents as we know them would diminish. That would have a devastating effect on swaths of sea life, which rely on particular paths of nutrients for survival, and ultimately lead to the mass extinction of species. Impact on our daily lives. While a moonless sky wouldn't affect most of our day-to-day lives, it would upend the lifestyles of many nocturnal animals. Animals like moths have evolved over millions of years to navigate by the light of the moon and stars. Newly hatched turtles use the moon's light to find their way to the ocean. In moonless Earth, they'll only struggle through thanks to artificial streetlights that lure them in the wrong direction. Also, we'd be more vulnerable to asteroids as the moon would be destroyed violently enough for it to break apart. And we'd likely experience a pretty violent moon rock storm down here on Earth. Plus, some asteroids stopping by to make their way down here. Without a protector, we'd be in the line of fire for more asteroids than we are now, which, as any dinosaur would tell you, could be very, very bad. Impact on Earth rotation. An errant moon would also affect Earth's motion about its axis. The pull of the moon currently increases the length of a day by about 2 milliseconds every century. Though if that increase stopped tomorrow, it wouldn't be very noticeable on our human timescales. However, if the moon had disappeared billions of years ago, our rotation today would be very different. Early on, the Earth had a 4-hour rotations, which the moon slowly and persistently slowed to the 24-hour days we know now. Without the moon's presence all those years, we'd still be spinning much faster, and feeling even more like there weren't enough hours in a day. The moon also holds Earth's 23.5-degree tilt fairly steady. Without that steadying hand, Earth would wobble much more, dramatically affecting the planet's seasons and climate. Moonlight will turn darkness. If you thought stargazing was awesome now, imagine how much better it would be without a big white light interfering with your view, and of course, when the sky gets cleared, the Earth will be overwhelmed with darkness at night. Eclipses would be no more. Whether you're talking solar eclipses, partial, total, or annular, or lunar eclipses, where Earth's natural satellite passes into our shadow, we would no longer have eclipses of any type. Eclipses require 3 objects to be aligned: the sun, a planet, and a planet's moon. When the moon passes between the sun and a planet, a shadow can be passed on the planet's surface, total eclipse. The moon can transit across the sun's surface, annular eclipse, or it can obscure just a fraction of the sun's light, partial eclipse. But without a moon at all, none of these could occur. Our only natural satellite would never pass into Earth's shadow if it didn't exist, putting an end to eclipses.